Welcome to section 12.13. This is the 139th session of the CISSP exam prep series. In this session, we'll survey the technologies that connect networks across long distances. What splits WAN links into two big families? What is a dedicated line, and where does cable internet fit? What counts as a non-dedicated line? How do you keep a carrier link fault tolerant? And what modern options carry the long haul today? Why does this matter beyond the exam? Because the wide area link is often the fragile thread holding a distributed business together. Picture a company with a headquarters and a dozen remote branches that must all reach a central system. The link technology you choose sets the speed, the cost, and the odds that a single failure isolates a whole site. On the job, you weigh those trade-offs and design the redundancy that keeps everyone connected. What splits WAN links into two big families? A single question. Is the connection always reserved for you, or does it have to be dialed up each time? That divides everything into dedicated and non-dedicated links. Whatever the type, a long-distance link can boost communication but also expose data, so you need solid connection management and encryption, especially over public paths. Think of it as the difference between owning a private road and merging onto a public one whenever you need to travel. What is a dedicated line? It is a connection permanently reserved for one customer, always on and waiting for traffic. Often called a leased line or point-to-point link, it joins two specific endpoints, and only those two, which is why businesses use it to tie multiple locations together as one. Over the years, these range from older telephone carrier circuits at modest speeds up to faster digital services, alongside legacy options that have mostly given way to fiber. Cable internet is a special case that fits neither family cleanly. It is always on, but it links your premises to an internet gateway rather than to another site, making it point to multipoint. And it is shared with your neighbors with privacy preserved by encryption, much like a VPN. Picture a dedicated line as a private bridge between two buildings you own. What counts as a non-dedicated line? Any link that must establish a connection before data can flow, and that can reach any remote system using the same kind of line. Classic dial-up modems are the old example, and digital subscriber line is the modern one, riding the upgraded telephone network to deliver a wide range of consumer speeds. There are several formats of it, each offering different download and upload bandwidth. Think of a non-dedicated line as a phone you pick up and dial only when you actually need to talk, rather than a wire left permanently open. How do you keep a carrier link fault tolerant? By refusing to depend on a single connection. For real fault tolerance, you deploy two redundant links, and for stronger protection, you buy them from two different providers. But check the fine print. If both providers ride the same regional backbone or share a major pipeline, you have not gained much. Even the physical routing out of your building matters, since one disaster or one careless backhoe can cut multiple lines at once. If a full duplicate lease line is too costly, a cheaper non-dedicated connection can still give you partial availability when the primary fails. Think of it as two escape routes that must not funnel through the same doorway. What carries the long haul in the backbone today? The segment linking local networks to a central hub or the wider internet is the backhaul, and a few technologies dominate it. A label-based routing approach is a common choice, tagging packets for fast, scalable routing across many locations with quality of service controls. Ethernet-based options like carrier-grade Metro Ethernet also serve backhaul well, offering high bandwidth and flexibility across towers, offices, and data centers. These high-capacity links increasingly move the enormous datasets behind modern analytics and model training, which demands strong end-to-end encryption to guard confidentiality and prevent tampering, together with heavy throughput and low latency. How do you reach places the wires do not? Through the sky. Satellite communication relays data between ground stations and orbiting satellites. And small terminal technology lets compact remote sites talk to satellites parked over the equator, which is invaluable, where wired options are impractical. Satellite broadband extends internet access to remote or underserved areas through a simple dish. A newer wave of low-orbit satellite networks cuts the delay that plagued the older high-orbit approach, aiming to deliver fast internet almost anywhere on the planet. Think of it as trading buried cable for a line of sight to the sky. What are the fringe and fading options worth knowing? A couple round out the picture. Broadband over power lines pushes high-speed data along existing electrical wiring, an intriguing idea that never spread widely, held back by technical hurdles, regulation, and stronger rivals like cable and fiber. And an older all-digital phone line technology was once meant to replace the traditional phone network, but cable, digital subscriber line, and fiber overtook it. So most of its service has been retired. Know these as context. They show why the market settled on the winners it did, even if you rarely deploy them now. So let's bring it together. WAN links split into dedicated, always reserved connections, and non-dedicated ones you establish on demand, with cable internet sitting off to the side as shared point to multipoint. Fault tolerance means truly independent, redundant links, not two that share a backbone. The backbone itself leans on label-based routing and Metro Ethernet. Satellite fills the gaps the wires cannot, and older ideas like powerline broadband and legacy digital phone service explain the roads not taken. Match the technology to distance, bandwidth, latency, and budget. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.